All right. Welcome, everyone. I need to work on that transition. It feels always, catches me by surprise. Welcome back, everyone, for a new episode of the Zephyr Tech Talks. I've stopped counting. Let me check. Yeah, it's episode 30. We've been doing this for quite a while now. Happy New Year, by the way. I'm Benjamin, your host for today, joining from France. Many of you probably know that by now, but if you're new to the show, joining us from LinkedIn, YouTube, please take a moment to say hi in the chat. That same chat that you will be able to use for sharing your thoughts and asking questions to our guests today. And today the topic, as you probably know, if you've joined, I can't believe we've waited that long to have AI on the Tech Talk. I don't think we've had maybe once in a while back, but of course, like AI is a big thing. And machine learning, I guess, the more boring way to call it, and it makes a lot of sense to do machine learning on embedded systems, right? To analyze and like do predictive maintenance when you take sensor data and you try and identify patterns in the vibration of your industrial machines or whatever. And so we have two guests today from Edge Impulse, now a Qualcomm company. Edge Impulse is a really cool set of tools, a framework. We'll see how our guests best describe it, but it makes it possible to do machine learning and again AI on really, really small devices. So that's what we're going to talk about. I'm personally really excited to be sort of catching up on what's new with Edge Impulse. Some of you may remember this this quote unquote artificial nose that I built a few years back, eventually migrated to Zephyr. It does machine learning with air quality sensors, and it does it with Edge Impulse. I think way back in 2020, I think I was one of the early users, I guess, of the platform. And yeah, I mean, you can read online or maybe we will talk a bit about it during the show. But without further ado, let's bring our two guests on screen. And I see some people saying hi in the chat, so we'll come back to that in a minute as well. Welcome, Francesco, and welcome, Eoin. You both are from Edge Impulse. You are joining us from where and who are you? So starting with Francesco, maybe.
Hello, everyone. So first of all, thank you, Benjamin, for having us here. We are really excited to join this Tech Talk. So I'm Francesco. I've joined Edge Impulse, I think, 4 years ago. I'm Italian, but I live in Barcelona, so Spain.
All right. And Eoin, and then maybe you guys will tell us a bit about your sort of like your background. So yeah, Eoin, welcome.
Oh, yeah.
Hi, everyone. I'm Eoin. I joined about 4 years ago. I think within a week from Francesco. I'm based in here. And so, I've been working with Edge Impulse in developer relations now for the last 2 years, I guess, and infrastructure before that. So my background was in DevOps and the kind of back-end technology, but I'm really excited to be with you here today. I know we covered MLOps previously, but since we joined with Arduino, it's just really kind of heating up and getting really interesting now as well. So I can maybe give a little bit of a brief on what Edge Impulse is. So Edge Impulse is a custom machine learning, embedded machine learning platform for training your own custom models that you can deploy to devices from MCUs all the way up to GPU-enabled devices. So anyone who's familiar with Arduino and what they do for embedded, we pretty much do that for AI. So we make it much easier to get your custom models trained and deployed to devices. And
right, I see. And so one thing, as I was sort of like recalling my own journey into machine learning for embedded devices, at least a few years back, like probably the only solution out there for actually running and doing the inference on the devices was TensorFlow Lite. And so at the time, I guess I would have described Edge Impulse as the platform to help you design and train your model really easily. And we'll probably see a bit like what's your sort of like workflow there. But then on the actual device, this would be under the hood, this would be TensorFlow Lite. I think this has probably evolved since then, right? Like now there's several silicon vendors and maybe other providers that have their own solutions for hardware acceleration and that kind of stuff, right? And I guess Edge Impulse supports some of those.
Yeah, we do support different NPUs, proprietary NPUs like Ethos from ARM, or the NeuralArt from ST. Let's say that for a basic flow like a Cortex-M or Extensa, we under the hood, it's true that it's still TF Lite running, but yeah, we do support different accelerators. So depends on that. It could be that under the hood, you can see something different, but yeah, the basic stuff, it's still TensorFlow Lite.
Yeah, all right, makes sense. And I guess, and also I'm throwing random thoughts or questions out there maybe already, but one thing also that I think might be worth mentioning is that, and you will guys tell me if you agree. So we're talking about embedded constrained devices, and there's this like big buzzword like AI, machine learning. People might think this requires lots of processing power. This requires acceleration. Maybe sometimes it doesn't. Like unless you do like computer vision and really like deep and like complex stuff for reasonably simple data processing on like time series data of sensor vibration, etc. I mean, it's nice to have the acceleration. It's not necessarily required, right?
Yeah. So we do all of our training on the cloud. So as well, like if you want to do what our platform does is it takes away all of the manual steps. Like you wouldn't roll your own CI/CD platform if you wanted to build an application. So what we do is we make it easy for you to get your data up onto our platform and start to work with embedded engineers and ML engineers, unlocking their skill set and getting visibility over what they do as well. And it makes it really easy to collaborate as well. So we've got experts from the embedded team like Francesco working with our ML team, and we're able to share our own domain knowledge easily through within the platform. We'll give you a quick end-to-end as well, just to show you where it goes from data right to deployment, and then where that diverges for our new Zephyr module and extension as well. So how we can connect back into interact with our platform. So we can do a really quick end-to-end if you want.
I was going to say, please do just that so that we can sort of like slowly get into the Zephyr aspect of it. But I think it's important that people understand the end-to-end workflow. So take it away.
Yeah, so I'm just going to share my screen here.
Alrighty.
So it all starts with data, really, our data, and we like your sensor fusion example that you spoke about earlier, that was time series data. And we've got our accelerometer, which is our X, Y, and our Z. And we can see here that we can connect a device. It could be your phone. It could be one of your Zephyr devices if you've got your data acquisition code written and connected, which we're working on at the moment for the module. But we've got some really great progress so far. So it starts with a sample that we can collect, and we can do that either with our mobile phone. Anyone who's attending right now would be able to, of course, I clicked the wrong button just now, but what you would be able to do is add some data here. If I go to data acquisition, and I could, oh, I'm clicking on the wrong screen, of course. Okay. So you could scan.
Don't click on the slides. If you click on your screenshots on the slides, it doesn't work.
So you can scan the QR code, and you can start to sample your data straight away, and it will be set to 1 second. You can crank that up to 10 seconds, and then you can start to record your data. Accelerometer is great because we can easily see our X, Y, Z, so we can see that clearly this is our Z axis, and we've got up, down movements happening here. So we can label that then as up, down. And once we get we've got 14 minutes of data here, but you can get a very usable proof of concept application with about 8 minutes of data. And you want to make sure that you have good balance within your classes here. So we'll have our up, down, and we'd have a snake. So this is for classification. If go to one of my snake samples here. And we give you a really visual representation of your data set as it's gathered. And this is all done through our UI right now, but we're going to see later that we can connect through any API as well, like the sample that we're going to see later for downloading our built model with the extension uses our API as well. So here I've collected 4 labeled data set. I've got my training data here, which is 80%, and we'll give you a warning here as well. So it really teaches you about the workflow by if you just sign up for an account on Edge Impulse and you get started, we'll take you through the steps right from data collection to deployment. And once we've got a number of samples collected here, we can go to create our impulse, and this is where we design our machine learning model, our AI architecture. So we can start with our processing block. So this is, we can apply some digital signal processing to the signal. So for spectral analysis, which is good for, and if you don't know much about DSP as well, or digital signal processing, we give you a very helpful hint here as well about, what applies to your data set, and we'll have a star next to it here. So you can use a spectral analysis here. You can add that block, then you can add your learn block. We said classification because we want to learn about patterns of our data, like our up-down pattern that we labeled. So we can add that one, and then we'll see that the axis are X, Y, Z. So if we had more sensors here, we could do like you did with the nose, where we've got the air quality monitor. We could add many more different data streams here, like our VOCs, or I forget what was in the multi-air quality sensor, but you could add a number of them here. And then we could even do anomaly detection. So we can detect things that are close to our label, but outside it slightly, and then we could discard that. So
it's sort of the first step of, and this is where I think, again, I've told that story before, and this is your tech talk, not mine, but for me, a few years back, machine learning was like this weird concept, and I really couldn't get my head around how do you turn like those hundreds of samples that you get from, say, your gas quality or air quality sensor. How do you feed that into kind of like that black box that will be identifying whether it's this or that? And turns out one of the things I was missing is the so-called, I guess, feature extraction, what you're just showing it here. For air quality, intuitively, when you think about, I'm measuring the variation of the concentration of CO2, etc. Really, what that means is that you will likely want to look at things like the moving average or the standard deviation of the values over a given period of time, and that's what basically this first step does. Turning potentially, I don't know, like if you're sampling at 1 kilohertz, you have lots of numbers, but they are essentially just the same because that value is not fluctuating all that much. So yeah, let's turn that into the average scalar value, and that's already like a first really important step. And yeah, all those tools really help make sure that you're already doing a good enough job at extracting things that are likely meaningful and that ML will make sense of. Or maybe simple if then else's could as well in some cases. Maybe you can also realize that. You can be like, hey, you know what? Feature extraction, that's enough. Like I'm good enough with the average. Forget about the rest. That could also be an option. Sorry, this is you talking, not me.
No, but you're totally right. And you bring up a great point because it is very limiting. So back, when we were, let's say we were learning about embedded electronics, we were maybe learning about Arduino, and we were building our first sensor-based applications. You're probably applying some thresholds for, a temperature sensor, or, if you're really lucky, you might have a color sensor here, like I have for detecting strawberries that I was doing with my daughter on the Mindstorms kit. You know, you can do some kind of clever things, or maybe you might do some edge detection with OpenCV, and you know, you'll get somewhere, but it'll be very painful. And this is kind of like why you would use a platform over, or a tool like ours as well, over why you would do it yourself, because anyone who's written, you know, from scratch, you can build an application that'll blink an LED, but it might, like, you know, it'll age you to get there. You know, if you want to extend it further. So yeah, take advantage of the tools that are available to you right now, which is AI and ML. So you can build not only rule-based applications, but now you can kind of like decide based on movements, like we did with our up-down. And like you said as well, you know, calculating the feature importance, which is the next step that we were getting to when we were building our ML architecture here. So we've got our DSP block, which is what we're going to train first. And like you said, we'll extract the features. We'll try and calculate the feature importance. We'll see which ones are important that we want to pull out and that we want to pass on to our neural network to do the classification and decide, is this really, you know, within our up down, our wave, or idle. And we brought in a new feature as well, which is really good for anyone who's interested in sensor fusion, which is normalization. So we can normalize across a range of different types of sensors or data points. And then that brings us on to the next point, which is our neural network. So, okay, I'm in expert mode here, so I need to just switch back, because anyone who's familiar with TensorFlow or Keras can see that you can write your own within our platform here as well. You can also work with us from within a notebook as well. We've got extensions for Python. It's just pip install edge impulse. And so this is our neural network. And we can configure all of the hyperparameters here that we want to train and tune our model, or you can just go with the default. And we've got an auto ML step, which is called the Eoin tuner, which you can run later, that will tweak all of these hyperparameters for you and get a very accurate result. And so yeah, we give you some measurements as well. And we can see here that this is the sample that we use from our documentation, because we've got 99.6% accuracy.
Point that out, yes.
Your mileage may vary. And then for our anomaly detection, we can see here again that we can, based on the features that were calculated as important, we can use those to factor into our anomaly detection. We can see here that anything that would occur outside of these, I think that's k-means, which is less elliptical than the GMM, but we've got a different set of anomaly detection algorithms that you can apply here. And we've also got a lot of different DSP algorithms for various types of data sets, like HRV analysis for wearables. So that's a really quick bird's eye run through of how you would build and configure a project. And then when you get to the end, you can run your training. Once you get to the end, you can get to your deployment. And this is the whole purpose of our session today, which is we're going to deploy it as a Zephyr library or module. You could as well do so for an Arduino library if you want to get started and you're familiar with Arduino. Zephyr is a great tool, and we're kind of assuming now that you've already got a basis in Zephyr today. But when Francesco takes you through the module installation and the executables that we have. So Zephyr, and we can apply some our Eoin compiler here, which will reduce your footprint more as well, up to 54% less RAM and 60% less ROM. So you got some room for your application logic and telemetry. And so if I build that, we're going to get, it'll just go through, this will go to our Kubernetes server, and it'll train it'll build and package our deployment. And this is actually fully customizable as well. So if you wanted to build your own firmware and kind of integrate into our platform, every piece that I touched today is highly configurable, and it's all available through our GitHub repo as well and documented in our documentation. So I think
a quick question from me, and this might actually come from the audience at some point. So I'd rather ask up front. By the way, people watching us, please make sure to use the chat to ask your questions or share your comments, whatever they might be. Eoin, what's the because I mean, Zephyr obviously is very much open source, free to use, etc. I'm assuming Edge Impulse is a commercial product, probably, but like, what does it take for people to use it? Like, is there like a free trial sort of approach and that kind of stuff?
Yeah, well, I'm glad you asked that, and I probably wouldn't have brought that up because it's an open source session, but I'm glad that you did. So it's free for students and free for exploration. But once you want to start to use us, then you can get an enterprise license, and there's also an evaluation period as well. So if you do want to work with us, our sales are very easy to work with, and you get about a 2-week session that you can explore with, and then there's an evaluation period as well. But yeah, for students and anyone who's exploring and wants to use us completely free, you get two. I think we've got more projects that you got 2 private ones that you can use, and then any amount that you want to use on public as well. And we've increased our training time as well. So yeah, we're making it much easier for students and for users to explore our platform. And if you want to sign up, I'm going to go very quickly to the end here. You can just scan the QR code here. We've got a very generous book as well from our from Jenny and Dan. Jenny on my team and Dan in our ML team wrote a book called AI at the Edge, and it's an O'Reilly book. And we've got a lot of training resources as well. So you can sign up for our platform for free, and you can download the book for free, and you can join Sean Himmel's course on Coursera for free as well. If you want to buy the certificate at the end, you can pay for that. And yeah, there's a lot of great resources out there right now for learning on our platform. So I'm going to, with that,
yeah, great. Thanks for clarifying.
Yeah. So I guess I can just hand over to Francesco now that we've got our deployment done.
Yeah. So thank you all for the overview. Just wanted to spend some words regarding the platform. So as embedded engineer, I think that's, as you explained before, Benjamin, so to go through, the whole flow of deploying a model can be pretty difficult, for someone that has a electronic engineer background. So I think that the platform really helps from starting from scratch, collecting the data, or even, downloading a data set and use it. And then starting from that, you can customize almost everything. You can use, for sure, the DSP blocks that are already there, training blocks that we have here, but you can add your own custom block, and then, different deployment option. You can start deploying for a specific target, a dev board, or a library. It could be a Zephyr library. So it really helps, to speed up some stages that usually takes a lot of time. So speaking about the Zephyr, so Eoin, it quickly show the deployment. We have this Zephyr module option in our studio. It's pretty recent. I think it was public like 3 months ago, because we saw that, a lot of people are using it. The community is growing really fast. And also more and more silicon vendors are using it, are writing driver for their target. So we saw here an opportunity to have the community to speed up their Edge AI application. So we started, because we already do something with Zephyr, to support a lot of Nordic boards that uses Zephyr for sure. But it was more, let's say, a library integration. So you had our SDK, our model, and then you had to manually tailor everything and manually integrate it. So studying all the functionality that Zephyr support, we saw that the module would be a good option for our SDK. So I can share a bit of code. Share my screen.
Meanwhile, there is a question which I will slightly paraphrase or reformulate from Vera Valley. I guess about footprint to some extent, like what is the main outcome products we can use with this one, and can we also use it on radio or baseband products? I mean, the way I read the question is like how small can it get to some extent, right? Because like those like radio chips, etc. Sometimes they have like very limited resources. So I guess short answer is it depends on the size of the model, etc. But
it depends. It depends on the size of the model for sure. How complex it is. We have some tool like the Eoin compiler that help reduce the RAM usage, but then it really depends on the model complexity. So for like time series model, it can just a couple of kilo of RAM, and then we can go up like for a video, image, this kind of stuff. Yeah, it can be mega, giga, whatever, it really depends then on your application. But the model that Eoin just showed, the continuous motion recognition, I think is just a couple of kilobytes of RAM. And then on the documentation, we also instruct how the user can move around the tensor arena or the weights to fit their needs. If you have a particular, if you need to relocate something in a particular section of RAM or flash, we have some define that helps doing that. So
Okay. Kind of a complementary question from Daniel. On which kind of cores does Edge Impulse run? I guess Cortex M is the sweet spot, but you're probably not limited to.
No, we're not. So again, it depends on the application. You can run a simple model on a Cortex M0. We do support that too. For sure, it doesn't have FPU or this kind of stuff, so it can be a bit slow. But for basic model, it is okay. So it really depends on what you're looking for. So usually for time series, let's say from sensor fusion with a not really high sampling frequency, it can be an M0, M4. And then for vision, we start seeing the needs for an M7. And then using the latest accelerator on the market, like MPUs and the new MF55 or M85. We do support a lot of MPU here, and as well we are aligned with CMSIS NN. So usually you take advance if you have any MAV extension, and we also do support for the SP32, like the S3. We have integrated their NN kernel, so you can take advantage there also for the accelerated instruction. So it really depends on your application, but we really support a broad range of architecture.
All right, thanks for clarifying. And I will be putting your screen.
So just to have a quick overview of our SDK. Right now it's hosted on a repo in our Edge Impulse. So it's not yet streamlined. We don't know if we will ever, because for us it's very important that the model and the SDK are aligned. They have the same version. So it could be tricky, let's say, to keep track with different projects with different model version that need different SDK version. But for now, it's in our GitHub repo. You can pull it. You can add to your West manifest for your project. This depends a bit, how you want to handle it. We explain, but it's already in the Zephyr documentation, which is the best way to use it. And our SDK, it has a couple of sample already there. Really simple one, the static standalone one. And then about the SDK itself, we have stuff for the running classifier, stuff for DSP, porting layer, that we have a bunch of functions that needs to be present in your application for specific task. But this is all explained in the documentation. We've added recently a couple of comments. let's say, make more easy the flow to build and deploy your model. So we added 2 additional commands. And yeah, let's jump to an example on our repo.
Tell me more about those, because I was actually really excited to see you guys using that. One thing I was mentioning, I think it was in the Zephyr podcast a few days ago. We are seeing more and more. Taking a step back in Zephyr, we have this thing called West that helps people provision and maintain their work environment, their workspace. So pooling basically all the dependencies, the so-called modules that a project might need, be they the HALs from the silicon vendors, third-party modules, like maybe Edge Impulse. And one thing we have in the Zephyr documentation is a way to document like all those GitHub projects out there that are third-party projects, but that happen to be available as modules. We do document them. And so many people start adding them, like connectivity comes to mind. I think the Wolf SSL people, they added the documentation for their modules as well recently. You guys did too. But one thing you did, which I think is quite interesting, is that you leveraged the fact that West, so this sort of like generic meta tool that helps provision the different modules, do the Git updates, etc., to make sure that they are always up to date. West also allows to define custom commands. So like those commands that you use to West flash an application or to West debug your firmware project, those are extensible. And so you, in your own SDK module, you added a couple commands. So yeah, I want to hear more about it and like what these commands do. I guess they sort of extend this whole thing of like West can help you make sure that you always fetch the latest of the Zephyr SDK, if that's what you want, the latest of XYZ, and also in your case, the latest version of the model that you've trained and things like that, right?
Yeah, so as Eoin quickly mentioned, basically our studio platform, it has a lot of API, okay, for doing different kind of things. You can upload data, you can do, I mean, you can really do anything that you want related to the platform for sure. And so we have also commands. We also have an API that allows you to build a specific project and then to deploy and for a specific format. It can be a specific target, it can be a library, whatever. So let's say we decided to extend and add this command to West, so a user can, from the line command, just invoke one of these 2 commands, and it can quickly build the latest version of the model. And then with deploy, it can download a zip file with the content as a Zephyr module. So I can quickly show that.
So random thought. I hope I won't be losing too many people, but this is a question that comes to mind for me. Would it be a possibility that rather than having like the SDK itself being a module, I guess you could output and like even almost like publish on GitHub whatever is the trained model, publish that as a module, and then you don't even need the commands anymore? Like, does that make sense? Like in my project, rather than pulling the Edge Impulse SDK as a Zephyr module, I would be pulling Benjamin's artificial nose and point to some kind of GitHub repo that you would, I don't know, like generate somewhere.
Well, you can have
AWS or something.
It's a good question. I think that what you can do, you can have like a project, a repo set up that can, with some GitHub action, can, I don't know how often it can then build. It can trigger a build and then a deployment on your project. I think this is a use case for sure. You can do that for sure using GitHub action. So instead of doing it manually, why not? There are a lot of possibility with these API. So this is one of them.
Yeah. Oh, that could be a cool example for us to do in the tutorial series. Just
like,
yeah, we definitely.
Yeah, not for Zephyr, but I'm doing that for SimSysPack. So when I want to test that everything is aligned, I have a GitHub action that build and then deploy the model into my repo and then build it and run it. So to test that everything is aligned, because as I said, it's really important that the SDK and the model need to be aligned, need to be synced. So this for sure can be done as well in a Zephyr project. In our roadmap, which is pretty open, and we would like to hear from the community, from you, Benjamin, what are your thoughts, your idea, your needs. There is as well like a task, an idea to enhance the testing of a project, and this, it is something that for sure can help in this case.
Yeah. So very quickly, will we go and just show again, just on your project, how you get your API key, and then we can show people how to run that EI build. Do you want to?
Oh yeah, sorry. I was reading the chat. Yeah, I was reading the chat. Let me show. So this example, you can find it in our GitHub. So it runs inference on IMU data from a shield, from an ST sensor shield, so from real data. So here we can quickly show the build command. So this is the command, WestAI build, the API key that is found in a tab in the project, and then the project number. So with this command here, we're gonna build the project, and then we can run the deploy. Okay. Yeah, it's not yet completed because it takes a bit, and this is another improvement that we want to have in place. So right now the command just triggers the build, but doesn't wait for the build to finish. So if you try it and you are too quick and try to deploy and the build is not finished, you get an error. So let's see if it's finished. Okay. So now we have a nice zip. We have downloaded the model. So let me unzip it. Okay, and we can see here the model at the end is just C++ file and either with a nice README that explain a bit the project name, the model version, and also it prints, that is really important, the SDK version that is needed for this particular model. So one thing that the user could do is to get this IML West, copy the revision file, and make sure that is the same of the project. So in this case, I was using the main, but yeah, let's reply it. And just in case, we can do a West update to check if the SDK that we have right now, it's the same one that is needed or need to be updated.
Yeah, right. Cool. There is I think something that probably is worth clarifying. There is a question from Arsh.
Yeah.
Can we not use TinyML in Zephyr then? I guess it's worth clarifying that whatever you guys do, I mean, of course, one can do TensorFlow Lite and that kind of stuff in Zephyr. Actually, we even have some examples of that. But there's lots of manual steps, I guess, involved to, like we mentioned really early on, like have your Python notebooks, etc., like to actually do the training, and then you need to export the model in some kind of like either you generate C header files with all the weights, etc. You need to figure out how to use that in the code, etc. You need to pull in the SDKs or libraries that you need to use, TensorFlow Lite or anything else. And I mean, to some extent, this is error prone and or not necessarily like fully packaged. And this is where I guess you guys come in.
Well, I guess Francesco, you have the CMake list there. You can show, how easily we can enable and disable flags like TensorFlow Lite Micro. You can configure it to run in TensorFlow Lite.
Well, the answer is yes. You can do directly use TinyML, add TensorFlow to your project, etc. But yeah, it's a lot of steps. It can be painful, to see the data, collect the data, and then do the training. It's really error prone. So our platform, I think the main goal is to make all these steps easy. Okay, you need to focus on what? On your application and on the model results, not in preparing the data and this kind of stuff. So then you can really focus on the important things. So you can do it by yourself, for sure. The platform, let's say, make it easier and allow you to spend more time in what really matters. So, and also, I mean, I speak as an embedded engineer. So for me, setting up TensorFlow, do the training, the model, it can be hard. It depends on your background. For me, it was, when I started, get interested in the topic, it was really like, wow, how can I do this? I need to learn, TensorFlow or Keras, whatever. With that, it really is up on the flow. You have a pre-configured blocks that you can use really easily. It's just a couple of clicks. So it makes your life easier, let's say. And so about this topic, I see a question. Does the platform allow loading our own model architecture? Yeah. You can upload your model. If you already have a trained model, you can easily use the bioham function that basically allows you to upload your model, and then you can again deploy for whatever you want. In this case, for Zephyr. So you're not, let's say, forced to use our flow. You can upload your model and then take advantage of all the deployment option that we have.
I guess kind of a related question from me. I think so. That artificial nose project of mine, when I migrated it to Zephyr a few months back, one thing that I was considering is there a way, or have you done the work to leverage Lext, our linkable loadable extensions, basically those dynamic libraries in Zephyr, where I would love to see basically a way to dynamically change the weights and basically upload the model on the fly. The architecture would likely remain the same, or maybe not.
So you're reading our mind. So in our roadmap, this is a big topic. So we started this integration like, okay, we see the communities using it. We see a lot of silicon vendors that are using Zephyr, that are migrating to it. And then we did the first let's say mere integration, have a module, and so on. Then we added the command. And then next, okay, the LLX is a big topic because it is something that could be really interesting. Because as you said, a lot of people, maybe you have your model, your weights, and you change it, but then you don't want to refresh everything. So for sure, it's something that we started to check if it is feasible, what can be the advantage, the disadvantage. Also, we were talking with our friends at Arduino, and they are using it extensively. So, it is something that it is in our roadmap.
And related, I think I know the answer to that, but something else that I would love to see, either like from Edge Impulse or from the community at large, how about on-device training or on-device reinforcement? Like I have already a vibration, like anomaly detection, fault, like predictive maintenance thingy that I've built, but I want to improve it based on the actual field data that I collect. Is there any support from that in either the libraries you use under the hood or in Edge Impulse at large?
Right now we do not support on-device training. So the answer for now is no.
Okay.
I don't know what's the plan here. I hear it time to time during our testing. but for now it's not on the plate. So
okay.
The hardware is just getting to the point now where that is really kind of feasible, I think, as well, isn't it? Like since we've joined Qualcomm, and we're getting up to 100 TOPS hardware and more. Maybe that time is coming, but I think it was kind of seen as, I know Sean Himmel did a talk on it maybe a year or so ago, and it was really interesting to see how kind of long that took to do its own learning. It was one of the pivot ones,
Right, and it doesn't have to be training from scratch. Like hopefully, doing just the small improvements on an existing models. Maybe this is slightly less compute intensive. I don't know.
We have model monitoring, but right now it's something just for Linux target. But we are really dynamic. I mean, we even though we are part of Qualcomm right now, we still have this startup phase. So if we see that something is really interesting, that we see a lot of value in it, that people really need it, we can change our plan really fast. So for now, the answer is no, but you never know.
The kind of option that we had was, we have this, you can kind of fork and diverge your impulse. So if you wanted to have different varieties of your model based on the same data, we can, that's where we have this impulse. So we can create a new impulse, and we can do experiments with the existing data. So we could have, like, let's say you wanted to have different models for different locations. You can also integrate us as well. If you want to build your own MLOps kind of workflow, you can integrate us, and even with the train and deploy, with the EI deploy command that we have now, we could connect that in and do our Git actions, kind of connect us into a CI/CD where data is fed back. And we've described some examples of how to do that. I think we did a talk on that before, actually, Benjamin, as well, with Blues. And maybe we could, So, about, you can totally integrate us and have a variety of different models for different scenarios, and start to model the drift with the model monitoring features that Francesco said. What examples do we have the model monitoring on? I think it was one of the Nordic boards.
I'm not sure. I don't remember, to be honest. Yeah.
But yeah, we're very dynamic, and that's what the kind of purpose of today's session was as well, to gather feedback from the community and kind of see how this feature is going to be getting used, and how we can extend it. And definitely, we're very encouraged to hear the Lext as well. So hopefully that will be on the roadmap next.
And so, we have about 10 minutes left. So please, people, share your thoughts, questions, feedback here. I guess something else from me, like in Zephyr, we obviously have like this very, you mentioned briefly that like the fact that we have many drivers existing, and that's maybe what drove some of your customers to ask for more Zephyr support, because they wanted to reuse the existing drivers. And when it comes to sensors, we have like a nice sensor API, etc. So out of what one generates out of Edge Impulse, like, is there already some hooks? Like, does it already tap into the sensor subsystem, and does it make it like easy for people to be like, oh yeah, okay, you have this model, and by the way, just tell me what sensor you want to plug it to, and you take care of some of the stuff. So I think that's maybe what you had on your slide with you want more samples sort of stuff.
Well, yeah, the answer is not yet. So because till now we used to, work on having a C++ library that the user have to integrate in a system, and in this case, it's really hard then to say, hey, I'm going to use this API, or so it was impossible, let's say. Or another focus was on specific dev board, so supporting a specific dev board, and for which you have hopefully the driver from the silicon vendor. So it was really specific. For Zephyr right now, it opens really a lot of possibilities, because as you mentioned, you have a sensor API. So in this case, it can be that we can provide a set of samples that are specific for, I don't know, a motion, a camera, a microphone. I started building different examples. You can find them on our GitHub. Right now we have the one for the MEU, which points some ST header. Eoin did one for a keyword spotting, so microphone. And then we are also working on a camera one. We have some issue with the camera. We are testing different targets. I see that maybe the camera is a good example, and because the driver is really generic. I mean, all different, different camera model. At the end, they use the same initialization, from what I saw following the example. So yeah, the goal is to have a set of samples that cover different sensor, and to help to help user to hook up their in their application the data collection stuff. Because a question that sometimes come up in our forum is how can I connect my sensor collection to running inference? Because if you check our firmware, maybe it's too complex to follow, and you have a difference, depending on the platform that you're using. You can have, I don't know, a thread or by pooling. So you can have different use case, and the users sometimes are pretty lost in that. But inside with Zephyr, we can get closer to the user application.
Yeah, and the Xiao's ESP32S3 is what I'm writing support for at the moment, because the ESP32 we get a lot of questions about on the forum as well. So we're hoping we'll have that camera example up soon. But yeah, the sensors one, that's really interesting. I can't wait to see how that works out, because we have maybe 70 different dev kits maybe 80 now that are supported, that when they're connected, you can see all of those sensors, and it makes it very easy to build a sensor fusion example. So it would be really cool to see that generic.
Yeah, or to feed the training data into Edge Impulse, like putting a generic firmware on the device first, so that you have a way to collect data, like something that just streams accelerometer data and whatnot to the studio, and then something that would basically work on virtually any board supported in Zephyr with an accelerometer on it.
The UnoQ is what we're working on at the moment, and that, funnily enough, doesn't come with a IMU, but I was trying to use one of the temperature sensors that was on there, because I didn't happen to have the same dev board as Francesco. He wrote a driver for the accelerometer, IMU actually. Sorry, it's got a gyroscope as well. The UnoQ, that one was working well, wasn't it, Francesco, as well?
Yeah, I've lost you for a second. I'm back, right?
Yeah, you're back.
Okay. I recently received the UnoQ, and I was like, let's see if it works. And it works like a charm. I've plugged it in one of these ST header on top of it, run an IMU model on it, and it works perfectly. So nice. That's pretty cool, because I tested this example on different platform, and I was a bit skeptical about the UnoQ, but it works like a charm. So that's perfect.
Yeah, it's really good.
Catching up on a few questions that we have in the chat, really just a couple, but someone on YouTube was asking about support for remote model updates. I think we answered that. Maybe you were not listening at the time, or Zephyr, but this is on the roadmap, right? I guess at this point, and potentially this would leverage LEXT, the feature in Zephyr, LLXT, which is linkable loadable extensions, the ability to load code or data at runtime, and so potentially you push the model updates over the air, sort of stuff. I think that's it for the question. So we are reaching the top of the hour. Francesco Eoin, was there anything else you guys wanted to share, and or people watching us? Now is the time to ask questions or to subscribe to the channels so that you get notified in the future of future tech talks and podcasts and whatnot. So yeah, guys, anything else you wanted to show or talk about?
I can add, again, we really just started with this Zephyr integration. So we are exploring the capabilities that we can have here. So really, if anyone from the community has a particular needs, feel free to drop a message in our forum, in our Discord. We are also just joined the Zephyr Discord. So we want to hear from you, what you see, something that's it's really needed and right now we don't have. We do have a roadmap, but again, it's super open. So right now our focus will be for the camera example, because I think it's a great topic. And recently we saw some silicon vendor that are targeting that. So this could be really interesting. Another stuff is, as you said, the next for sure, and then improve our command to extend that, to add some kind of test on that, so you can run on your CI some testing regarding that nothing has broken. We are going to support more NPUs because there are new NPUs that I see that are supported by Zephyr. So for sure we want to add the deployment for these NPUs. And we gonna roll out other examples. So I don't know if Eoin, you have anything to add?
Yeah, I just wanted to say as well that the point of this was to make it much easier for people. We had a lot of issues with people on our forum who were getting started with C++, placing directories in the wrong location, CMake, all of that kind of thing. So just another vote for trying it out this way. You really can't make as much mistakes. It's, as Francesco demonstrated there, you run a couple of commands and it's populated for you, so the structure will be there. So yeah, I think just give it a go and let us know how we can help or improve it. Thanks for having us today.
Sounds good. So that's the contact info. Discord is usually a good way to hang out with the Zephyr community. It looks like it's the same for Edge Impulse. And with that, I think that's the wrap. Folks, if you have more follow-up questions, feel free to drop them in the chat or like in the comments section rather of YouTube or LinkedIn, and I will make sure they get answered. And we will be back in a few weeks' time for a new episode. Francesco, Eoin, thanks for joining me today. Bye.
Thank you.
Thank you. Bye-bye.